So now we're just going to finish up our talking about angular momentum as a vector and how to calculate energy, which is not a vector but a scalar. So here we have our angular momentum vector here, and we know that it's going to be some I matrix times some angular velocity vector. And so then when we multiply this out, we'll take these times this, as we do with vector multiplication, where I x is going to be the integral of y squared plus z squared dm, and we're going to have our I, y. This is the middle term. These are the diagonal terms, so they will always be positive. X squared plus z squared dm. So just y means that it's the distance from the y-axis, so y isn't in here. We got z is going to be x squared plus y squared integral dm. And then now these off diagonal terms, and we put them with a negative sign here, because now we can just say I x y is going to be the integral of x y dm, and we have our I y z is going to be the integral of y z dm, and we have our I x z is going to be the integral of x z dm. All right, so this tells us how to calculate all the terms in this matrix, and then this multiplication tells us how to get our angular momentum vector. And now if you want angular momentum about a fixed point, then all of these terms are about a fixed point. If we want angular momentum about the center of mass, then all of these terms are about the center of mass. Now, what about energy? Energy is a scalar quantity, so we have to get all of these terms into our scalar quantity, and it just looks like this. So we're going to have our kinetic energy T, and if we have it about a fixed point, we're going to have 1/2 omega dotted with h about a fixed point. Or we can also calculate it like this: T equals 1/2 omega dotted with h about g. That's a vector. Plus, and now we're going to have the motion of the center of mass. So v bar dotted with the linear momentum vector, where the linear momentum vector is just going to be our mv's. So this is just going to be 1/2 mv squared. And this, in the case of a symmetric system, would just be our I omegas. So it would be 1/2 I omega squared. But now, if it's not symmetric, you're going to have some of these off product terms.